You already know what nuclear energy is if you looked at the first section of this course, the series of podcasts, whatever. I don't want to call it a course, but it's basically a series of podcasts. I take different books. In the beginning, I explained how sun is producing energy. We keep saying sun's energy is unlimited and it'll never be exhausted. Sun is having a reaction going on called nuclear fusion, where two hydrogen molecules crash and produce so much energy that it becomes uncontrolled, and when they merge or fuse they produce something called helium, which is twice the H2. So H2 is 2. If you don't know, don't worry about it. It's chemistry. You will come back to it later when you get older. So nuclear fusion is when two molecules fuse together, and that produces lots of energy. But on Earth we are also doing a lot of things called nuclear fission. Do you know that atoms, if you don't know what atoms are, don't worry about it right now, but if you do, then you probably know that it has a nucleus with protons and neutrons, and there are electrons floating around, and all these are held together by huge amounts of energy. And if you find a way to split open certain molecules, atoms, then you can release that energy, and that's what is called nuclear reaction or nuclear energy. Let me start by offering my apologies. Says an atom. On March 11, 2011, the worst earthquake in Japanese history took place. It wasn't my fault. It's just a natural event, but it triggered a tidal wave called tsunami that you may have heard of. When Earth moves and the ocean moves, sometimes it starts off a wave. How do you think of it? Let's say you tie a rope at the end of a one end of the rope to a pole, and you move the other end up and down, and you see a wave going, right? So that's what happens when earthquake happens. A wave in the water called tsunami can happen. So it triggered a tidal wave. Actually, tsunami is not a tidal wave, but we use this in general. Tsunami is a Japanese word which means harbor wave, because it comes into the harbor and wipes lots of things. So it's a wave that caused a disaster in the nuclear power station of Fukushima, which is a place in Japan. Everyone who lived in the area had to leave at once. Since then, there have just been wild boars wandering around, and occasionally people in scary suits who are trying to clean up the land. That's going to take a long time. Okay, so basically when nuclear accidents like this happen, radiation is released like sun's radiation, but when it reaches here, it's safe, because remember, in the upper atmosphere what's happening? The harmful radiation called the ultraviolet radiation is being trapped by the ozone. Ozone is being formed, fortunately, in the upper layer, which absorbs the dangerous UV. But when nuclear accidents happen, many dangerous radiation amounts are released, and that can be deadly. So people wear very protective suits to go into these places. I'm not involved in many disasters, but when it happens, there is a serious consequence. That's because nuclear power stations work with uranium. You see here uranium rock, which is a radioactive substance that can be found in the ground in many places, occurring naturally. Like everything else, uranium is made up of atoms, and atoms are made up of even smaller particles which I hold together with a lot of energy. So you can tell that I am incredibly strong. Without me, everything around you completely falls apart, because we are all atoms, and atoms are held together. If they start flying away, then flying apart, then we'll have a lot of trouble, right? In nuclear power stations, they split the nucleus, the inside of the atom, releasing me. My energy makes water boil, and the heat can be converted into movement. Just like water can flow and turn turbines, steam can flow and turn turbines and push the piston and so on, and you know the rest of the story. Because you have a nuclear reaction, you need a cooling station because it gets tremendously hot, and then you use that heat to produce steam, and then you run turbines or pistons, and then you produce energy, and that goes into the lines, grids, and then comes into your house out of the socket on the wall. And that's the symbol for nuclear energy, because you have electrons orbiting the nucleus, and the nucleus has protons and neutrons and so on. If you don't know, do not worry at this point. So why am I the best candidate? I don't depend on water, I hardly release any CO2, I don't pollute the air, and there is enough uranium for now if you wanted to produce all the energy with uranium. Why does it matter if it needs water? Well, as we said, water is a very precious commodity. We drink it, we use it for growing food, we use it for industrial activity, for washing our clothes, and so on and so forth. So water is very precious, and the less we use it, the better it is for us, right? So take that. There is enough uranium for now. Yes, I also have my weak points. As always, there is always a catch. When there is a disaster like the one at Fukushima, lots of radiation is released. I really wish that had not happened, but did you know that it caused no deaths at all? Well, you have to be careful, because that's not necessarily true. I don't know why this book says that. Okay, the radiation means that people in the area have a higher chance of cancer and other nasty diseases, because radiation causes damage to your DNA and your body and causes cancer and so on, which is also awful. Of course, the disaster areas will be uninhabitable for decades, because the radiation has to be washed out, cleaned out, and made safe for everybody. And the repairs are costing more than $188 billion. A billion is 1,000 million, and a million is 100. It's 10 times 100,000. In India we call 1 lakh, so 10 lakhs is a million. It's 1,000 million is a billion. It's $188 billion, not rupees, right? But you know there are deaths in coal mines too, so it's never free, it's never safe, it's always dangerous. And what about the millions of deaths all over the world because of air pollution? That has nothing to do with nuclear power, but can you compare this way? Well, people are breathing polluted air without realizing it, and even when they realize it, they think, well, I cannot do much, or maybe they will wear a mask. But nuclear power scares people. A nuclear reactor in your neighborhood near you will make you run away. Your parents may get scared and say, let's sell the house and go somewhere else. Because when it explodes or something goes wrong, it releases radiation that can kill. You can always say it hasn't killed many people. But now people are trying to build safer nuclear stations and smaller nuclear engines and so on and so forth. So maybe by the time you grow up, nuclear will feel so safe that you will be having one in your backyard. It will be small enough to run on these radioactive fuel for the nuclear reactor. But there are other things. Once nuclear power has been generated, the remaining material is called radioactive waste. Uranium is used to make nuclear power, but what remains is still radioactive, and that has to be stored somewhere. It's typically stored in a mountain deep inside safely, but where is that mountain? The state where the mountain is, or the people around the mountain, again have to be told that they are living near nuclear waste, so people can get scared. So this is all very psychological. So even though you can say it's safe, people have to believe it and get used to it. So what did you say? Another disadvantage of nuclear power and myself? I had almost forgotten. Yes, I do leave some radioactive waste behind, and yes, the radiation is harmful to humans and animals and will remain so for tens of thousands of years. You produce energy, you produce waste. That waste is going to stay for tens of thousands of years, and it's not safe for humans. So if prehistoric people in the Stone Age had had nuclear power stations, then their waste would still be dangerous for us now after thousands of years. This means that we have to store the waste so that it is safe for tens of thousands of years and does not leak. Even during wars, floods, earthquakes and meteorite strikes, it has to remain safely hidden. But hey, there is always a catch for everything we think is sustainable, renewable, safe, and so on. So here is a person in nuclear safe costumes, standing on drums and drums of nuclear waste with the signal here. And in Fukushima, where the accident happened, it's radioactive and people don't go and the animals don't know. So they are wandering around and maybe they have cancer and maybe they have 5 legs instead of 4, because things get deformed when they are exposed to nuclear waste and radiation. We know this from before. Okay, so nuclear power is renewable and sustainable for now, but we don't know necessarily how to make it completely safe. So just remember that, and talk to your parents, teachers, brothers, sisters, friends, neighbors, and so on, to understand more about nuclear power and see who is scared of it and who thinks it's very safe. So try to learn what makes them think it's safe and what scares people, because you have to decide for yourself also if you think nuclear power should continue or not, and whether it's safe enough or not, even though it is renewable. So we'll come back and see which of these is the safest and the best. Sun, solar power, wind energy, water energy. We talked about biomass. We're talking about nuclear energy. We talked about geothermal energy. So many options. None of them is perfect, but what's the best one? We'll come back and discuss. Okay?